All right, question number 10 looks like a review. We're going to perform the first derivative test, locate critical points, use those to locate local minimum and maximum, and then identify the absolute maximum and minimum values of the function. So our function f of x equals the square root of x times the natural log of 5x. Domain is 0 to infinity. Find the derivative. We're going to use the product rule. So first function times the derivative of the second would be 1 over the argument. Sorry, 1 over 5x times the derivative of the argument, which would be times 5. First times the derivative of the second plus the second function times the derivative of the first. Derivative of square root of x is 1/2 x to the negative 1/2 power. All right, cleaning this up a little bit. 5 will divide out, leaving me with square root of x divided by x. Here, the natural log will multiply to the top, 2 on the bottom, and then this will be square root of x on the bottom because the 1/2 power, square root, negative, puts it on the bottom. All right, so plus natural log 5x divided by 2 square roots of x. Set this equal to 0. Multiply through to get rid of the denominator. So 2x square root of x. We'll multiply that through on both sides, pretty much the whole thing. Multiply times 0 still gives you 0. Multiply times this function, the x will cancel out. The square root times square root will be squared, and then it will cancel out, leaving me with 2x. And then multiplying the 2x square root of x times this term, the x and the 2, sorry, the square root of x and the 2 will cancel out, leaving me with x times ln of 5x. All right, here we can factor out an x, leaves me with 2 plus ln 5x. All right, so then we just set both of these equal to 0. X equals 0. X cannot be 0, not in the domain. And then we have 2 plus ln 5x equals 0. Subtract 2. Negative 2. Write this as a exponential, so the base e, move it over. So e to the negative second power is equal to this. So we get 5x is equal to e to the negative second power divided by 5. X equals e to the negative second power over 5. So this will be our critical value. Critical point. E to the negative second divided by 5. this says locate the local maximum value. All right, so we're going to put this on the number line and do test points. So this is 0 to infinity. This value, just round this to about 3. Let's just say 3. 3 squared is 9. 9 times 5 is 45. So it's going to be a relatively small number. So let's just say we're going to test 1 over 45 is about 0.02. If I look at 1 over 50. So let's test 0.01. Let's just say 0.01. We'll use a calculator. And on the other side of that, we'll use the whole number 1. So this is e negative second divided by 5. We are going to, let's just go to y equal. We'll type in the function. Square root of x. Natural log of 5x. Looks good. Don't really care about the graph, just the values. So I'm going to type in trace 0.01. That's going to be my first test value. 0.01 gives me a negative. That's negative 0.0299, whatever. But I'm really concerned with the sign, so this section is decreasing. And then on the other side of that, I'll just type in 1. So this is plugging that into the function and giving me a y value. When we plug in 1, we get a positive value. So this goes from negative to positive, so that goes through a dip. So that's like a minimum. So we get a minimum. So the local maximum, there is not a local maximum. We got one critical point and it's a minimum. Locate the local minimum value that is found at x equals e negative second power divided by 5. All right, now it says identify the absolute maximum. So we would test the endpoints. However, in our domain, 0 is on one end, and we cannot use zeros in parentheses. Infinity is something we never reach, always moving toward it. So I can't even test endpoints, so there's not going to be an absolute maximum value. All right, and then identify the absolute minimum. It wants us to type the exact answer, so this is not one. Normally I would just plug it into the calculator, but we can you can see what it would give us, but they want the exact answer in terms of e. So even if I were to type in this value to this function, which will be e raised to the negative second power divided by 5. And that gives me about negative 0.329. All right, so it's something really small, but we're going to plug this into the function and get the exact answer. So we're going to do f of e negative second divided by 5. It's going to be square root of e to the negative second divided by 5 times ln of 5 times e to the negative second divided by 5. So here, I can think about this as let's just rewrite it as square root 1 over 5 times e squared. And so when you do this part, it's like saying square root of 1 on the top over square root of 5 times e squared. We can take the square root of e squared to just divide this by 2. So with this part, we'll get 1 over square root of 5. And we'll have an e come out. Over here, 5 will cancel out 5, leaving me with ln e to the negative second. Ln has a base of e, so e will cancel each other out, leaving me with a negative 2. So we'll multiply this by negative 2, and that gives me negative 2 over e square root of 5. Again, we can rationalize the denominator, but I'm just going to type this in and just verify it matches with what we saw from the calculator. So the negative 3.29, I'm going to type this in and see if we get negative 3.29. So go to the home screen, and then we'll type negative 2 divided by e square root of 5. I think that'll work out. All right. And we get that negative 3.29. So that does match up the decimal expression. That's the only way you can really check that. Exact answer in terms of e, negative 2 divided by e square root of 5.